Once you start to understand a few things about asynchronous Rust, I think you'll become a much better asynchronous programmer. First thing to talk about is what kinds of async are there? There's async standard and there's Tokio. Essentially, not many people are using async standard. It's not very well supported. When you look up tutorials, when you include libraries into your code, they're almost always going to rely on Tokio when it comes to asynchronous code. So if you're doing something async, you're probably going to be using Tokio. Tokio starts with this function called tokio main. It's a little macro you put above your main function, and it allows you to run asynchronous code. But the thing people don't usually show you is what this is actually doing. Somehow this macro is just taking it so that you have a main function and then magically you can run asynchronous code. Well, how does it do that? And the secret is in what tokio main, the macro, actually does. And what it does is it rewrites your code like this. It doesn't do anything too magical, but it replaces that section of your code with this call that creates a runtime. And that runtime basically allows you to use keywords like await, asynchronous keywords, stuff like that. What the runtime does is it basically tells the compiler and tells your computer, hey, we've got this thread, we're doing some operations in it, but we might create other threads. Then it helps control things like when to pause a thread, when to sleep a thread, when to switch between threads, how to make parallel execution happen, all the magic that comes with an async program. So now that you know what tokio main actually does, you can see how asynchronous code works. This is code from my video game project that you can access at rpgfx.com. It's a browser-based game that I've written in Rust that I'm still working on. It's going to be a big, fun MMO game. A bunch of people can play together and fight monsters and go on quests and adventures. I hope it's going to be a great time and a lot of fun for people to play. A lot of the asynchronous code I have here is related to one of the most common use cases of async. And let's talk about those use cases. One, networking. So generally, one of the most common use cases of async code is when you're doing anything over a network. It makes it so that the game client connects to the server and then receives data back, such as where your player is, where other players in the game are, quests, your inventory, stuff like that is all transmitted asynchronously. And that can't be done non-asynchronously because you never know how long that's going to take. And if you try to make that code non-asynchronous, where you're just waiting for the response and not able to do anything else, your program's going to lock up, your user's going to be clicking things and they're not going to be responding, and they're going to be having a poor time. Another use case for async is in file system access. Sometimes you could be accessing files that are many gigabytes in size, and that kind of call out to your operating system takes a long time. Reading data from the disk is an expensive operation. It takes a lot of time for your computer to go out, find the file that you want, bring that data into your program, load it into RAM, and then give it to you for your program to access. A third common use of asynchronous code is in doing something parallel. So say you're processing a very large file, you could break it up into smaller chunks and send each part of that file into different threads that will process the file and then return an output cleanly back to you. Hopefully this has helped you understand asynchronous Rust a little bit better. My name's Ryan, and this has been Rust Me Up. Happy crabbing!